Each year, U.S. emergency medical services respond to about 240 million 911 calls. 11.7 million of these calls are life threatening, including cardiac arrest or stroke, with the first 5 minutes have proven critical for the victim's survivability and long term health. Life threatening situations require timely emergency response. For example, the American Red Cross found that every minute, survivability decreases by 7 to 10% for out of hospital cardiac arrest. This becomes a large scale issue when considering that the average urban and rural response times are both beyond the 5 minute threshold, with the national response average over 15 minutes. Reducing US response times by 1 minute is projected to save 150,000 American lives and $7 billion in healthcare expenditures yearly.
We are Reflex, consisting of undergraduate students Amelia Abernathy, Reed Blanchard, Nevin Gilbert, Akash Harapanahali, Usman Jamal, and Lauren Wright. We are a team of 6 Georgia Tech students with a mission to answer one question. How might we reduce resource disparities between urban and rural emergency response by delivering life-saving medical equipment like AEDs via drone within the critical intervention period of an emergency incident? We decided that there needs to be a way to deliver life-saving medical equipment to victims in rural areas as fast as in a large urban area. Resource disparities combined with slower response times, lower funding, and fewer trained medical professionals put rural Americans at a severe disadvantage when it comes to accessible life-saving devices.
Currently, there are two main methods used to reduce this disparity. The first centers on making medical equipment less scarce. To this end, Heart Hero, a medical device company, has developed a 1.3-pound AED, easily storable in a backpack, reducing both size and cost significantly. While this addresses the scarcity issues, chances are only a subset of the population will be able to have a Heart Hero AED on hand when an emergency incident occurs, which leaves the total accessibility problem unaddressed. Another solution improves distribution through reducing barriers to receiving equipment. Archer EMS achieves this by delivering defibrillators with drones. Though still in testing, they plan to implement this solution in urban Florida counties. While this solution benefits urban residents, the challenge is more pronounced in rural areas. Our solution derives from both methodologies. We plan to make drones more accessible where they're needed most, rural America. More specifically, we're targeting national parks. Our technology utilizes drones to allow for more ready access to AEDs where they were previously unavailable. Drone technology's increasing prevalence in the urban healthcare space and Zipline's success in rural Ghana demonstrates clear potential for a rural AED delivery system. Additionally, studies have validated the effectiveness of drones in response in rural areas. One finding that drones on average arrived 19 minutes faster than ambulances to emergency sites.
In our over 65 interviews with 911 call centers, healthcare professionals, and emergency responders, we have identified an ideal early adopter in the form of the National Park System, which is disproportionately affected by emergency response times due to unique terrain challenges, reduced cell reception, and staffing. Justin Jager, the regional aviation manager at Grand Canyon National Park, expressed interest in drone delivery of medical supplies, as the technology is already used for search and rescue and will be our first customer. To better characterize the Grand Canyon as a good candidate, let's take a look at their emergency statistics. Each year, the national parks has an average of 1,067 EMS incidents. Approximately one-third of every fatal incident at the Grand Canyon is due to sudden cardiac arrest. In 2018, there were 11 cases of cardiac arrest, where only 2 AED shocks were administered.
We are currently in the process of designing an attachment to drones currently used at Grand Canyon National Park to deliver medical supplies around the park faster than the traditional process of rangers hiking to emergency locations. Our solution is intended to enhance ranger response, giving personnel an additional resource instead of replacing current protocol. Our team has been receiving guidance from Dr. Gary O'Neill of GTRI and Dr. Kelly Grindling from the School of Aerospace. Our advisor, Dr. Grindling, has personal experience in drone startups and technology, which has proven an invaluable resource in our initial development. With their help, our team decided to purchase a DJI Phantom V4 Pro drone, which we received 2 weeks ago and have begun testing with. In addition to gaining flight experience and preparing for the FAA Part 107 test, acquiring the drone has allowed us to begin prototyping our minimum viable product.
Over the break, we'll continue iterating our initial attachment designs for fabrication in the Invention Studio in January. Over the course of the next semester, we plan to test and design our MVP on the Phantom drone before transitioning to the Grand Canyon-specific drones. By next fall, we'll use this traction to apply for Georgia Tech's startup launch, where we'll be able to acquire funding and experience to begin testing directly in the national parks. Given the current pandemic, it is clear that the healthcare infrastructure is in need of automation. Using drones to deliver medical supplies ensures faster response, better connection to care, and a more consistent distribution of equipment. Our service enhances current EMS by filling in the gaps. At Reflex, we aim to save lives. We'll see you in 2021. Thank you.